So, hello, and welcome back to my small little operating system development stream. Today, part 3, without facecam today, because it's way too hot. Holy shit. I also don't know how long I will stream today, because of what. But anyway, let's start where we left off the last stream. And I don't know what we did, to be honest. Let me just... Oops. Let me just catch up with everything. Exactly. I created a bugs to fix txt file because I noticed two little bugs we had after I ended the stream. And we are going to fix them fast before we proceed to order. Because we forgot to give reads direct the starting OBS number. Exactly. Here. I labeled this wrong. This is actually I totally labeled this wrong. This is the starting OBA, which is 1. I think. Let me just fake check. Right. I think that's okay. And we forgot to exactly we created last time with our makefile the OS binary, but we didn't selected the OS binary in our boot script. So let's do this here and see if it's still is it still able to boot. This would be great. It is. Okay. Cool. So then I would say, what do we have to do? Yeah, I forgot. We need to do the A20 line check and turn it on. But first, let's try to load the second stage of the bootloader and see if we manage to get this to run. But we need to do this in 16-bit. So let's just do this here. Let's just do it here. For this we need Ralph Brown's interrupt list again, because I don't know. Yeah, extended read. What do we need to do? In AH32, in DL the drive number, and in SI the disk address package. Okay. As not as the address of the, I would guess. Cool, let's try it. We move into, firstly this, we move into 41. And we move into DL Oh, save. We move into the outer drive ID, I think I called it. And into SI, we move the, how did we call it? Way too long name. We do this. Okay. And then we call in 13. So CF is clear if it is successful. Cool. That means this here is actually read loader. No, this here is prepare 32-bit. Then read so we jump if carry is not set to prepare 32-bit. Otherwise, we move into SI. I think we already got an error message for it. Read error message. We move into SI to read error message. Did I shorten error? No. And then we print it. We print the error message and we halt. Right? Carry if clear. This shit should totally work. Let's just double check our data package. Yeah, try it. Let's try it. We make clean. Let's see if it builds. It does, and let's see if it boots. Oh, we didn't get an error. Didn't get an error. I think that should work then, I guess. Do we have something? Ah. Well, I think it worked. You know what? We tried. We have everything done here. That means what we are going to do now is we take this out of here, put this into stage 2. And just jump to stage 2. And then we will see. Yeah, we also need to do this. So let's try it. Let's make it. Let me just firstly check something. Yeah, size is about right. Cool, let's boot it. And it's crashing. Shit. Okay, no problem. We look at it. Let's look at the debugger and see what is happening. So let's just look at it. Let's just move over. I moved too quickly. Shit. Okay, no, wait. Let's do it again. Something is going wrong here. Something is going horribly wrong. Actually, it's a pointer, please. Next. So. I accidentally. Wait. I braked at 7E00. But it looks like there is none there, which is a problem. Oh, wait. I mean, this shouldn't be an issue, but. What the fuck did I just do? Shouldn't be an issue. Okay, it seems like our data package isn't really working. It's not loading anything. What? Yeah, oops. Don't annoy me. Nah, this is wrong. I mean, we don't need to set the CS register. So it's just make plain. Let's make it. Do it again. By the way, exactly like this. It looks exactly like this when our kernel crashes. In this case, it's only our bootloader. It just restarted and restart itself in an endless loop. And when it's doing this, we know it's crashing. And let's just look why. I mean, I think I know why we got actually. Oops. Wait. Can't use this. We break at 2. So. Okay. So let's just look at it. Step I. What are we doing so? We are here. So exactly we're here. Then we move the L into here. We call inf in, yeah. What? What is happening? This is not good. What's happening? I mean, is our error message working? This shouldn't be a problem, but yeah, okay. Hmm. Something is not looking good, yeah. Let me just check something. I have a bootloader test project. I need to check something in there. Can't but is something wrong with our data package? I guess. I don't know what, to be honest. Hmm. So I got this two here. We get no, actually all is looking pretty good. Look at this. This here actually what is the issue? What is the issue here? Is our file? I mean, we should actually fill all of this with 0, but this is not a problem because we got our this here are 512 byte, yes, and then we got our code here. Oh, strange. No, it's 0, but this shouldn't be a problem. Okay, now. So, what is your problem? What is your problem? I really don't know. Let's just double check. But I mean, it doesn't return an error or extended read. Let's just double check if we got something wrong there. Or extended read. Ooh, yes. It's 42, not 41. Oops. It's 42. I wrote 41. Genius. So please work now. First back again. Please work now. Okay. Cool. He has a problem with our reading. Clear if successful. CF set on error. And we jump if the carry is not set. Jump not carried, that means there is an error. In the error code is in AH. That means we step in our debugger and look at AH. I think this is a good idea. So, okay, let's do it. So, one we call int30. Why do you still have 41? Or are you... Is this the check? 41 is check extended read. Okay, and 42 is the next one, yes. That means here is the extended read. I have questions. What are you doing, my friend? So we make it the right one, yes. There was error reading from disk. Okay, that means he falls in there. Yes. Now we don't have a symbol file. What are you doing? Sometimes I hate assembly. I wish we just had a nice debugger. You know. So what's happening here? Yeah, no, we are. I think we are here somewhere because we call remove. '41 into H. Into all. And then we call the interrupt. Wait, is this the interrupt code? Oh, fuck. I think I know where I get confused. I stepped in the interrupt. This is my mistake. Oh, it would be great if I could use if I could use GBT step. Wait. I want to. So we not step, we make next I. Whoa. So now we shouldn't step into the routine. DDB, what are you doing? Hello? Okay, you know what? Let me get. I think it was this. Then we continue. Okay. Anyway, we are here now. We are here now. I don't really understand. Why he goes into the int instructions when I say he should step over, but you know, I don't care. We just do this. Oh no. Okay, let's look at the AH, right? Error code. We got an error code of 1. So now we need to find out what this error code actually means. We need to find out what the error message is. This? Are this the error codes? Invalid function in AH or invalid parameter? I mean, I don't think so, because we literally have 42 into AH. There is nothing we can do wrong. Why is there one? There is not much we can do wrong, eh? Let me just break it. Let me just break there. What is your problem, my friend? So now we are before we call the interrupt, and let's look into AH. We have 42 there. Yeah, because there is actually is the drive number correct? It's 80. Yeah, 80 is a valid drive number. God, okay. Oops. Are you correct? I mean, you look correct. Not nothing. Is our DS register correct? Is maybe? Ah, it's 0. Okay. That means the error has to be our data package. I mean, I don't see. Oh, or invalid parameter. I didn't read it completely. Yeah, I think our problem is the data package, but I don't know what could be wrong with our data package. I mean, I double checked it. Let me just try something. I want to see something. Guys, it is annoying, I tell you. What is your problem? Please tell me. Let me just double check again. We got. Oh, wait a second. This is. Yeah, but this was of error, but I made this error later. It should have worked before. Ah, okay, cool. I switched up a D and a B. Wow. Oh God, sometimes I hate assembly, yeah. And now we are in stage 2. Holy shit. Yeah, but why? I mean, I know that I had it like this at the beginning and this should work totally fine. I mean, I made this error later. I don't care. It's working, yeah? It's working. We have now split our bootloader into these two beautiful files. Oops. And now we can jump to our new stage. Isn't that beautiful? So look at this, we are now going to make a function out of it. We are now making a function. Because we also want to load the kernel with the same method, with the extended read, and we obviously only can do extended read in the BIOS functions, which includes extended read in 16-bit mode. So we also need to load the kernel here, this means we are going to make a function out of this. You can go away. Let's do it under the print function. Extended pizza. Is it actually function? No, I'm wondering. I think I make this function blocking. You know? That means that so this is our extended read function. Then we write what it expects. Expects. What does it expect? Expect. You know what? Let's do it like this. It expects a pointer to read package in package in SI. Did my stream just crash? I think my stream just crashed. Hey, I'm back. Okay. Hello. My stream just crashed for a reason. Anyway, but it fixed itself. Okay. Anyway, we were at Okay. Anyway, let's just point to string and then it expects the pointer to the error message. And it expects it in the what register we are going to use for this. We are going to use the how is it called? Extra segment. Extra segment is the ES register. And ES. So, and now so then we also write what it modifies. It modifies the AX, the DX, the SI, and the ES register. Okay. Then we can delete this. Cool. This function should totally work. As everything I do, yeah. We just saw it on the read package. Oh. Now we read the loader. For this we move into SI the I should stop with long names. We are going to move U in there. And then we are going to move into the extra segment, the error message. I just don't know how I call all my variables. What I wouldn't do for auto completion. But I'm too lazy to set this up in NeoVim. I already did it for C, and this was a pain in the butt. So I don't want to do this for a little bit assembly we have to do. And now we call extended read sum. That's just right. It has a problem. 53. Invalid combination of opcode and operand. Ah yeah, oops. I tried to use a fucking segment for it. Stupid. Nee, we are going to use the... Where is all my shit? Let's just abuse the DI register for it. Fuck it. I just deleted something. Fuck. So, are you booting? Yes, you are booting. Now let's try our error handling in this function. Let's just give it a totally wrong data package. 100, so. Hello? Why? Did I save it? I just gave you a totally wrong data package. Hello? Okay, maybe it realizes it? Ah, okay. Yeah. This is 1 byte. This is 1 byte. The package size, and I give it 100 in hexadecimal. But it still shouldn't work because it just has 0. Then does it have error correction that it defaults back to 10? I mean, it seems like it. Then we give you here wrong number. Who cares? Don't have a clean all directive. Yup. Error handling is working. Just funny that it can actually handle this. I think what is happening here is if we give it garbage, in this case the BIOS realizes it and just defaults back to 0x10 because it only can be one of these two values, but it's interesting that it does this. But okay, I mean... Cool. You know what? Let's just keep it... Ah, shit. Let's just keep everything the same and do it like... do this. So. Now it's pretty cool. Okay. So the last thing we have to do before... No problem. Wait. The calculator can actually do a lot of cool shit. I learned it all from a tutorial. Can actually also do 64-bit here, but it was everything hidden. But yeah, you have to set it on programming for it to work. But funny. Okay. So. Yes, it is. I think it's better than the Windows calculator actually, because you can actually manipulate here the single bits. I just think this is great. Yeah, way better than Windows calculator. 100%. So, the last thing we have to do. I mean, it helps a lot by programming this bit manipulation, what the calculator can do. It's great. You know. Okay. So we just, yeah, we need to check for A20 line, and then we can actually jump to long mode here. No, not in caps. Oops. So. Okay. You know, because we have the calculator, I just find it extremely strange that you can't shift more than 15 bits in this menu. And you can actually... Oh, you can. Never mind. I thought there was a limit. They hard-coded this limit to 15, but it seems to work if you do it by hand. Never mind. Okay, never mind. So, we need to do the A20 line. Check in here. How many bits we have left is the question. How many bits do we have left in our bootloader? What was it? Around, we have enough left for the check. Okay, that's great. So A20 line, we need to enable it because what A20 line does is instead of type. What do you mean in terminal? Oh, lol. I never knew this. Okay, that's cool. I always was typing clear pretty often because I like a clear terminal. But that's cool. Cool stuff. Thank you, my friend. Oh shit, I deleted... I forgot. I actually wanted to do it like this. Not that I'm... Last time I do it with move, this is completely stupid. So. And AX, cool. Okay, so A20 line, I always forget. This is the last check we have to do in 16-bit mode. And then we can actually prepare for 32-bit, 64-bit mode. And then we can actually do our kernel in C. But once we are in 64-bit mode. Isn't that great? Cool, okay. A20 line, exactly. We need to enable A20 line. because I can actually show you guys on the OS dev wiki what it does. But I heard a sound. Hey, thank you, Nova, for following. You are my first Twitter follower. You're welcome, my friend. Hey, you know what this means? It means my alerts are working. Hey, thank you, thank you. Nova. You know what is cool? Now I can actually activate this here. Look at now that now that I have a follower, you can stand there. Isn't it cool? That's really cool. Okay, so where was I? 8:30 light, exactly. I actually have my own documentation for it. I show you this. This is cooler. So, I have a 20-line documented here. This is basically what it does. A 20-line truncates if it off, it truncates the 20th bit just away. So addresses like this turn into this if we don't enable it. This is stupid. This is here's a, if you guys want to know, you can read this. It's like old stuff because everything is backwards compatibility. But if we don't enable this, it's going to annoy us. That's why we have to enable it. So how do you enable it? There is a fast A20 gate, exactly. But there are multiple ways to actually enable A20. We are using the fast A20 gate because it's extremely easy. And this works like we do it here. A20. If we have like this, we just do this. And write it to this port. And that should enable it. Very easy. Now there's a funny way to test it. There is a extremely funny way to test it. Because I showed you that one bit gets truncated. So what we can do is we basically how do we do this? Oh, what's this 20 spiff? Where are you? You are here. What we basically gonna do is we write into a memory address like this. No, you know what we are not going to do is because it is not recommended at all to write into random memory addresses. But basically, what one instructor once does, what I think was funny, he has created a random memory address like this, write a value to it, then removed the 20th bit, write a different value to it, and if a 20 line is on, then logically this bit didn't get truncated. And on this address and on this address are different values. But if A20 line is off, this bit, when he writes into this address, gets truncated to that. And then when he wrote to this address, there was the same value on this. You know what I mean? Yeah. I hope it's understandable. But I thought this was funny. But this is not recommended at all to randomly write into memory like this. No, wait, we can do it. Because if we use an address like this, this is, let me just get the memory map. I think this is okay because this is anyway our memory. So this shouldn't be an issue. Usable memory. Yes. That means this here is totally in our usable memory. This heißt we can do with it what we want. So we can also write to it. Okay, let's do it. Let's do the funny check. Because I think this check is funny. We test for A20 line. For this, we just write something to this. We just write something. A random value. Let's just write this. Then we also need to check. I think this value works. Like because if we shift it for byte. It go back, please. Let's just use. I have. Okay, but we need this. We firstly need to Control AX and move this into the ES register because we are going to use to shift this as a segment register. Oh no, I need. This should work. Right. Because if we have this address 80D0, first of all we have this. Then we multiply it by 0, so we shift it. Oops. We have this, then we shift it by 16. By 4. And then we add this. We get, if we remove the 20th bit, we get to this address. This works. This works perfectly. Cool. Now we write something totally different there. We will E200. So, and if A20 line is on, then if A20 line is on, that means on this address has to be this value. Yeah, because we write it to it. But if A20 line is off, then this value is at this address because this value as I showed, got truncated to this value, and then we just exit our bootloader. But there are a lot of ways you can enable a 20 line, but past a 20 line should be okay. For now, I mean, we can always change it if we have a more stable OS. But for now, we just 20 line error. We just fail it here and visit it somewhere later. A 20 line is on off. Yes. I think the user can actually enable it in the boot and in the BIOS, not in the bootloader, in the BIOS. So it's not our problem. User has to do it if he gets this error. I don't care. Here. Please enable a 20 line in star. So. Okay, now we just need to compare it. And then we jump if we are always jump. We want to jump if we are help me. We want to jump if it is equal. Yeah. I mean, yeah, that's cool. I could have figured this out by myself. If this is equal. Then we jump to ended read. And if not, we write our error message. Okay. So how did I call it? I already forgot. A 20 line error message. Okay. Then we write it. And we also block here. So let's just look at it if I did something totally wrong. Being stupid? I don't think so. Cool, let's try it. Oops, what is... Ah, wait, you probably want... We need to word. I guess that you are happy. Okay. Okay. A 20 line seems to work, but now our disk reading doesn't work anymore. What happened? Let me just... Why? I didn't change you. Let me just see if my error message works by triggering it. 20 lines off, please enable. Ich habe enable mit 2 geschrieben, cool. I wrote it with 2 E's. Please enable. So. Our error message works. This was the wrong way. No. Please enable. Yeah, good. Works. No. Holy shit, I can't spell today. Okay. Oh, wait. Now I can use the combination shortcut. Cool stuff. So why is our reading broken? I didn't touch you. Hello. So jump if you are equal. That means why are you broken? Ah yeah, I forgot to fix you when I debugged you. So and we got our T, our blue T from stage 2. That means we successfully loaded stage 2 into memory and jumped to it. Okay. Great. I think we got now everything covered. What I wanted to do in 16-bit, we checked A20, we read the next stage, we prepare 32-bit, we jump into 32-bit, and 32 into protected mode, we have a GDT. Everything is just working. Cool, that means the next time in part 4 when I'm streaming again, we actually can prepare for long mode. And what do we have to do for it? We have to have a valid 64-bit GDT, and we enable paging, and we also need to have a valid page cable. Then we can jump to long mode and to see journal entry. Then we can finally write code and see, holy shit, I only write a little bit assembly and I'm already sick of it. I want auto completion. Okay. Ah shit, I forgot the partition table. Yeah, this is a problem for future me. Because QEMU doesn't want one. QEMU perfectly boots without one. But real hardware, because old real hardware, often wants to have one. This is where we need one. But not now. Okay. Cool. Okay, we didn't manage to do much this stream because we had a hard time with our beautiful read package bug. But that's how it is. Cool. Then I had fun today, yeah. I stream. Yeah, I have a schedule which is sometimes accurate. I accidentally forgot to stream on Monday, but today I managed to do it. And the next stream should also be listed in this schedule. Yeah, so, thanks to Aglo, if you're still there. For my first real viewer, I had a bot watching me before that wanted to sell me live viewers in chat. Anyway, have a good one. To the next stream.